They protect against wear, against rust, against water damage. What are they? Nano coatings and nanostructured layers, only billionths of a meter thick, thinner than a fiber of silk. They can be applied to objects to repel water, improve visibility on a computer screen, or hide aircraft in the night sky. From semiconductors to sunglasses to solar energy, nanostructured surfaces are all around us, and scientists and engineers are working on new applications every day.
When people use these terms such as nanostructured or nano-enabled structures, they typically mean that let's say this composite or this type of material has some components or constituents that are in the nanoscale.
Jay Guo is a professor of electrical engineering at the University of Michigan, researching nanoscale structures with funding from the National Science Foundation. He's developing microscopic coatings thousands of times thinner than tissue paper that can control how light interacts with an object's surface, with potential applications in LCD displays, solar panels, and radar deflection.
I really like the science behind these nanostructures, and especially how I can make use of them for engineering applications.
One way Guo's group structures nanosurfaces is by adding materials to the surface of an object. Here, they place a glass plate into a vacuum chamber and add carbon-mixed gas.
Heat it up and then open up.
The chamber is heated to a certain temperature, and carbon nanotubes, long, thin, tube-shaped molecules, begin to grow on the surface. A surface coated with nanolayers of carbon nanotubes can be engineered to absorb light waves, to reduce glare on a computer screen, or possibly even make an object seem invisible.
The coating here is multi-layer coating. I think this one has 5 layers. But we designed the structure such that it absorbs the entire visible light.
Guo and his team also fabricate surfaces by removing materials through a process called etching, which creates nanoscale grooves on a surface. Inspired by the morpho butterfly, which appears blue because of nanoscale structures in the wings that reflect blue light wavelengths, Guo's team etched surfaces that absorb or reflect certain wavelengths of light. This structural color research is being developed to improve LCD screens and to create more efficient solar cells. Guo also designs nanoscale films, several thin layers stacked, that reflect selected light wavelengths, such as red, white, and blue, while using the absorbed light to generate electricity.
Basically, you design your panel to absorb certain portion of the light. So you can produce different colors, or you can produce white colors, and so on and so forth.
Other nature-inspired research comes from water repellent and self-cleaning plants, like lotus leaves, which are naturally covered in nanoscale bumps. Scientists and engineers have manufactured super hydrophobic or water-resistant nanostructured surfaces and nano-layered coatings that cause water drops to bead up and roll off, removing dirt and debris as the droplets pass over the surface. Similar surfaces and coatings will soon be used every day. Water and dirt-resistant fabrics, anti-icing surfaces on airplanes, house paint, roof tiles, all examples of products that have been structured to repel moisture. Specialized coatings also protect steel bridges and ship hulls. And medical instruments with specially engineered surfaces resist bacteria.
I think we're going to see more and more nanoscale structures that is used in our daily life. I think certain technologies that people are exploring right now, even in the laboratory scale, I think some of them will be able to transition to the real world that benefit people and the society.
With real-world applications that range from food preservation to self-cleaning glass, it's clear that nanotechnology will have a big impact, and that Guo and other scientists have only scratched the surface of its incredible possibilities.